Hello everyone and welcome back. So today we'll be talking about simple regression model. So this concept is very important because it marks the starting point of your uh, deeper understanding of econometrics. So we'll start more thoroughly from here. So this is an important concept. Okay, so let's begin. So regression analysis is basically concerned with the study of dependence of one variable, say y. So we have a variable y which is dependent on another variable x. So your regression is basically this study or this finding of the value of x or regressing the value of x of regressing the value of y for different values of x. Okay, so we in here try to study the dependence of a variable y, which is also called the dependent variable. So this is your dependent variable. Okay, and this is your independent variable. Independent variable. So we are concerned with the study of the dependence of variable y on variable x. So for different values of x, we'll get different values of y. Okay, so we are concerned with the average value of y for different values of x. So this is your simple, or this is about regression. So in order to estimate or in order to calculate the value of y uh, based on the values of x through regression, we'll have to create a model. So just like we had talked about model creation in the first lecture, where we were trying to understand what econometrics is. So we tried to understand economic models. Okay, so we'll try to create a model here, a simple regression model through which we'll try to regress the values of y, okay, based on different values of x. So okay, so let's move. So the goal here is very simple. The goal of simple regression model, so I'll call it SRM. So the goal of SRM is very simple. SRM is to explain explain one variable in terms of the other. So y is being explained in terms of x. Okay, so in another way I can say that x is somehow causing y. So the direction of causality goes this way. Okay, so just keep this in mind. Since x and y are correlated in some form, so the direction of causality in here goes from x to y. So just let's take an example. Example can be, suppose there is a society and we are interested in calculating the number the number of crimes in the society given the number of police officers. Okay, so my interest here is, so my y variable is number of crimes and my x variable is number of police officers. So my concern is to check that whether increasing or decreasing the number of police officers in a society or in a community affects the number of crimes in that society or community. So this is something I can regress through a simple regression models. Okay, so these types of relationships can be uh, captured through your simple regression model. Okay, so the requirement here for this calculation to happen is there should be a population of interest. Okay, so in this case, the society in which we are trying to capture this relationship, that is our population of interest. And then we have two variables which I've already mentioned here, this and this. Okay, and we are interested in studying how y varies with x. So this is the area of interest that I want to study. So let's create a simple regression model. Okay, so my SRM model would look like, so y is equal to beta naught plus beta 1 x plus nu. So this is a simple regression model, and this is the model for the entire population. So we can also call this as population SRM regression model. Okay, so we'll also talk about uh, sample. Okay, that is your sample regression model. Uh, so since we can't have the data for the entire population, so we'll go for sampling. So in that case, we'll have a sample regression model. So we'll talk about that in the later stage. Okay, so right now we are talking about the population regression model. So your y will become your number of crimes. Your x is the number of police officers, and your u is the other factors. Other factors that affect crime rate. Okay, so these factors can be maybe unemployment, maybe low income levels, or lack of education. So there can be multiple factors that can affect your model or the relationship that you're trying to capture. So that is all captured by your error term that is represented by nu. Okay, so this is your simple regression model. So 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 when we write a model, the issues that we face during regression are, so the following issues are faced by writing a model. So let's see if our simple regression model help us eliminate these issues. So these issues are, the first one is, how do we allow factors other than x to affect y? So how do we allow factors other than x to affect y? Okay, then the second one is, what is the functional relationship between x and y? So whether y varies directly with x or x x square or with 3x. So what sort of function relationship are they following? That is also an issue that we face while creating a model. Okay, the third issue is how can we capture ceteris paribus relationship between y and x. So these are some of the issues that we face while creating a model. So let's just see whether uh, our simple regression model, which is here, can help us deal with these issues. So let me write the model again. Y is equal to beta naught plus beta 1x plus nu. Okay, so the first question that comes is the question of how do we allow factors other than x to affect y. So that is allowed by adding this term here, new term. So this allows us to capture the effect of other factors. Okay, let's see the second question. What is the functional relationship between x and y? So in simple regression model, the functional relationship is linear. Linear. So x is of the y variable is a degree one variable, the x variable is a degree one variable. So the relationship is linear. Okay. And the third question was how can we capture ceteris paribus relationship between y and x? So so we assume so we'll talk about this at a later stage about the third question. So we'll just discuss this in a while. So before that, let me just explain a few other things that are relevant for the simple regression model. Okay. So this is y, this is x. So this is called the dependent variable. This is the independent variable. And now this is also called the explained variable. X. Let me rewrite this. Explained variable. This is called the explanatory variable. So these terms can be used interchangeably. So I just want you to know that these are the different terms used for um, expressing similar meaning. Okay. Then this is all the response variable, and this is called the control variable. So you'll come across this control variable term very often. So just don't be confused. Okay, I hope you'll remember this. Then it is also called regressant, and this is your regressor. So these are the terms that are used for the variables x and y. Okay, that define x and y in some way. So and then we have u. So u is your error term. Okay, also called the disturbance term, and it allows us to capture all the other variables that might be affecting our dependent variable. So other than the dependent variable that we are actually concerned with, and all the other variables that might be affecting our dependent variable, that is being captured, or their impact is being captured by you. So model allows us to capture the effect of other variables, effect of other factors or variables through u. Okay. So beta and beta naught. So these are called your population parameters. Population parameters. So these are the things that we need to estimate. So the entire game is the estimation of these parameters, because this is this is your this is your slope. Because if you see this equation, beta naught plus beta 1x plus u, so it's like, if you try to compare this with a straight line equation, this is also a straight line. So this is your slope. So by how much? So if I change x by 1 unit, by how much is y changing? That is being captured by this slope term, that is beta 1. So how real is the impact of x, or the change in x on y? That is being captured by beta naught. Sorry, that is being captured by beta 1. This is beta naught. So the entire game is to estimate the values of beta naught and beta 1. Okay, so that's what we'll focus upon. So the third question that was put up. So the third question was, how can we capture the ceteris paribus relationship between y and x? Just a second. So uh, SLR addresses this issue. So SLR addresses the third question. Question. So we have y is equal to beta naught plus beta 1 x plus u. Okay. So if suppose I change beta 1 x plus delta u, so this becomes delta y is equal to 0 plus beta 1 into delta x, or x plus delta u. Now since I know that all other factors are fixed via your ceteris paribus assumption, therefore this term becomes 0, so it will not change. Okay, because it is capturing the impact of all other factors only. So in a way delta y is equal to beta 1 delta x. Okay, or beta 1 is equal to delta y by delta x. Okay, so the model is capturing the ceteris paribus relationship between y and x. So other factors being fixed, we can say that the model is able to capture the relationship between the variable y and the variable x. Okay, so in a way, um, so okay, so that's all. I think I hope this was helpful for you. So we'll move ahead further in the next video. Thank you for watching.